Hi, my name's Stuart Lynch, and welcome back. In the previous video in this two-part series, we built a flexible theming system using an environment key and a binding to an app theme struct, allowing us to switch between different color schemes dynamically. But as we explored, a few issues surfaced, and that's what I want to address in this video. So let's dive in and enhance our theming system. As I pointed out in the last video, there are some issues. First, dark mode doesn't work well for our themes. As you can see here, as I switch between the different themes, that dark background just doesn't work. Second, if our modal sheet is set to display without one or with a large presentation detent, when the sheet advances to full screen, the presenting view drops and reveals the background. And I want to change that somehow. And finally, there is no persistence to our choice. I want to save the selected theme between launches of the app so that it doesn't always revert back to the spring and it stays with the user's choice between launches. I do have a GitHub repository for this video and you can download it from the link in the description. There are 3 branches, so make sure that you download the completed source code part 1 branch. The completed branch part 2 contains the completed source code for this second video in this 2-part series. A link is in the description as well. That starter branch contains the starter project for the first video in the series. Just download the zipped archive then for the completed source code part 1 branch. The first issue to tackle then is the dark mode issue. There are a few ways to do this. We could go back to our theme and pass in an additional property to set our function that would indicate if we're using dark mode in our app, and then return different colors for our themes. And then in the background view modifier, pass in that same property, letting us know if we are in dark mode and remove the opacity, if that's the case, since it's the opacity that is revealing the dark background. I still don't think that that's really a viable choice. Another option to go with in this with background view modifier is to place a color of white behind our rectangle and ignore all safe areas so that 0.3 opacity will shine through to the white and not dark. In dark mode then it looks the same because that 0.3 opacity is just showing that white background. The other issue though is that our labels and text are using the standard light and dark mode text colors, so in dark mode the white on some of these backgrounds isn't very good, so you'd have to go back to your app and update all of those items, applying a foreground style for your text views, etc. that would work better in dark mode. So let's go back to the view modifier and remove that white color background. Well, for me, the easiest solution is not to even allow the user to use dark mode and force the light mode versions that you have here. This is not such a bad option since you've already moved that glaring white background and replaced them with your backgrounds. And that's really easy to do. Just go to where the app launches, where app main is. And the first view that's presented is the Start tab. So what we can do right here is apply the preferredColorScheme modifier and specify light. From now on, all views in your app will always be in light mode regardless of what your user's device preferences are. If you're enjoying this video, please give it a thumbs up and leave me a comment. And make sure you subscribe to my channel and enable notifications. You can also subscribe to my weekly newsletter. I'll leave a link in the description. The newsletter will provide you with more information about my latest videos, along with what's coming up, plus some extra bonus material. Now, if you enjoy my content and want to support my work, you can buy me a coffee. If you really enjoy it, you can become a monthly subscriber and receive early access to all of my videos before they're released on YouTube. The next issue is the presentation detent. This dropping down of a view, unfortunately, is what happens when a modal sheet is presented, and I found no way to color that background. To demonstrate this again, let me remove the presentation detent. Now I've found a workaround. If you are not using a presentation detent, you could use a full color sheet instead. This will present the entire view over the presenting view and there is no drop down. However, I want the option of the presentation detents, and I want to be able to use a large detent, and we saw this will cause a problem. And the workaround I came up with is to create a custom detent. So first, let me bring back the presentation detent and return this full cover sheet to just a sheet. Well, I have a full video on presentation detents, so if you're not familiar with them, you can watch that video. A link is in the description. What I'm going to do is to create a custom detent so that it will be as close as possible to the height of the large detent. So let's create a new file and call it max height detent. We'll need to change the import to SwiftUI. Inside there, create a new struct of the same name, but have it conform to the custom presentation detent protocol. Well, this is going to require a static height function with the context of the presenting view and return a CG float. Well, this context has something called a max detent value, which is the actual height that would be used for the large detent. And what I found that is if I scale this back to 99% by multiplying by 0.99, when the detent is presented, it doesn't drop down the presenting view. And we can make this work just like a real detent by creating an extension for PresentationDetent. In here, I'm going to create a static variable that I'll call max height to match the name of our detent. And that's a presentation detent that we can return as a custom detent, where the detent is our max height detent type.self. So I can return to the home view now, and let me add a new detent into this array, and I'm going to supply our new one using that static max height. Notice how it's available to us through code completion. Now, when we present the sheet, you are first in the medium detent, but I can expand that to the max height, and you'll notice that the presenting view does not drop. This is exactly what I want. The one downside to this is that you'll have to use a presentation detent now, even if you want the large scale one. You'll have to present the sheet with a detent of max height. So let me put the medium back now. And then the third thing that I want to do is to persist my choices between launches. So what I'm going to do is I'm going to store my choice in user defaults as AppStorage. I've got a problem though. AppStorage doesn't store our custom type. So I'm going to have to encode it and save it by making it conform to the RawRepresentable protocol. The other problem though is that our theme must be codable, and right now it's not. None of its properties in fact are codable. Season is an enum though, and since it's a string, we can conform it to the Codable protocol, and that's going to solve the problem for that season property. Tint and background, however, are color types, so we can't use a color. So instead, I'm going to create my own Codable color type that will be codable, so that when we instantiate our theme, we will still be able to pass in a color, but my initializer will convert those colors to codable colors so that our entire struct will be codable. So let's create a new file called Codable color. Change the import to SwiftUI, and then create a new struct called Codable color, and have it conform to the Codable protocol. Well, a color can be expressed with 4 double properties: the red, green, blue, and opacity. They are all doubles. Now, as I said, when I create one of these codable colors, I actually want to provide a SwiftUI color that will convert and apply the red, green, and blue values of that color to these properties. So we can create an initializer that's going to pass in a color, and we'll use an underscore so we don't have to use the label of type color. And inside the initializer, I can create a UI color using the UI color class and instantiate that color with the color, because that's one of the UI color options. And then we can start within the initializer by creating 4 variables for red, green, blue, and alpha. And all of these are going to be CG floats with initial values of 0. Well, this UI color that we created has a function called getRed, which we can use and pass in all of our new variables as references. And this will set the CG float variables to the correct values. It updates these in place. Well, now that we have those all set, our red, green, and blue, and alpha, what we can do is we can set the version for our struct, the self versions, to the equivalents, making sure that self.opacity is the alpha. With that done now, we can create a computed color property for our codable color called color that is a color view constructed with the red, green, blue, and alpha arguments using the properties from our struct. So I can return to our theme struct now and change our tint and background to codable color types instead of color types. Well, this will break our set function because it's supplying a color. So we'll need to create an initializer for this struct that accepts colors instead of codable colors. And then it converts those colors to codable color types, and then assigns them to our properties. With that in place now, we can make our entire struct conform to the Codable protocol because all of its properties do. Well, our app is still breaking because our tint and backgrounds are no longer colors. When we apply them to our views, they're codable colors. But each of our properties, tint and background, are codable colors that does have a color property. So in Start tab, the tint will become the tint for the app theme tint.color. And then each of our background modifiers must use the background's color. After you've done that, your app will be back to normal and we can still change our themes. But our struct is now codable, so the next step is to make it persist. So now that it's codable, we can conform our struct to the RawRepresentable protocol so that it can be stored directly in user defaults with AppStorage. I've got a full video on this topic, and I'll leave a link in the description. In your theme file, create an extension to theme, adding conformance to the RawRepresentable protocol. And this is going to require 2 things. First, a raw value that will be a string. So what we can do then is construct that string by encoding our theme object and convert the encoded data to a string using UTF-8. So we'll use a guard to form the data by trying to use a JSON encoder to encode self, that's the object, and also form the theme string by converting that data to a string using UTF-8. If that fails, then with an else, we can return simply an empty JSON object as a string. If it's successful, however, we can return that theme string. Well, that's what we get when we need to save to AppStorage. When we retrieve it, we'll need a failable initializer that will provide us with that raw value string. So it's the reverse process. So with that string, then, we can use a guard check to get the data from the raw values string data using UTF-8. And then within the guard, we can get an instance of the theme by trying to use a JSON decoder to decode from the data into a theme.self type. Now, if this fails, we'll return nil. Otherwise, we can specify that the instance itself will be that decoded theme. Now, there's one more thing that we'll need to do, however, and I explained that in the video on RawRepresentable. We must also provide our theme struct with its own coding keys implementation. So back in the theme struct, we'll create a coding keys enum of type coding key and provide cases representing each one of the three properties, namely season, tint, and background. Now we'll need an initializer when retrieving from AppStorage, and when we retrieve from AppStorage, it needs to be decoded. So it's an init from decoder with any decoder. And it's in here where we'll create a container that's the result of trying to use the decoder's container keyed by the coding keys.self. And then for each of the properties, we try to decode for each of the keys. So self.season is the result of trying to use the container to decode the type season.self for the key season. So I can just copy this then and change season to tint, and the type is a codable color for the key tint. And I'll copy one more time and just change it to background. So going the other direction, then we'll need to encode to an encoder using any decoder. And that's a function. It's the reverse of the decoder. So first I create a variable container using the encoder container method keyed by our coding keys.self. And this has to be a var. Then I can use a try to call the container's encode function to encode self.season for the key.season. And then I can simply copy this and repeat it for the other two properties. All we have to do now is to go back where we created our app theme state property. And instead, let's comment that out. I'm going to create an app storage property, and we can provide a key like app theme. But the variable name and the default value are going to be exactly the same. And this will act as our binding for our environment key. There are no errors, so let me run this in the simulator to see if I can get it to persist. The default theme is, as you see, spring. So let me change it to something else, like winter. Now in the simulator here, I'm going to exit the home screen before I quit the app. That makes sure that the app storage is saved. And I'll launch it one more time. And I see that the winter theme has persisted. We now have persistence, and we fixed our three issues. Just one more check then. Let me switch over to an iPad and run it here. Of course, we are back to spring as this is the first launch, but I can change that to another theme like winter, and it will persist. I want to check the modal sheet on an iPad because I haven't done that yet. And I see here in full landscape mode, I get the iPad modal sheet that's different from an iPhone modal sheet. It pops up into the center. And it'll also give us those two presentation detents that we have, the medium and the large. But let me go into split view on this iPad. And I'm going to open a Safari browser on the right-hand side. You'll notice that the tab bar has changed now for my app and is behaving more like an iPhone now. When I present the modal sheet for the Wi-Fi password, we get the iPhone behavior, but my max height is working here too. Perfect. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember I have a full SwiftUI course available on my Teachable site where you learn how to build a fun, multi-targeted app.